Welcome back. I am Anshu and you are watching Bottleneck. This is the Agentic AI Cookbook series where we explore and implement design patterns for AI applications using hands-on example. Let's do a quick recap before we dive in. In the previous video, we started implementing a content creation workflow or a content generation workflow, which is an example for context cascade pattern. Along the way, we broke down the use case into smaller, manageable steps. We designed individual prompts for each steps. We implemented each prompt using a LangChain expression language. And we also touched on context engineering and why it plays a critical role in agentic workflow. Alright, if you missed that video, I will share the link in the description. In this video, we will continue with our implementation of content creation or content generation workflow. Now, just to quickly set the context, an end-to-end agentic workflow typically includes context like RAG, prompt engineering, state or history, memory, and structured output, all of which we had discussed in detail in our previous videos. For this use case, we intentionally excluded RAG since our content creation workflow is generic and not tied to any specific domain. Retrieval isn't required here. We will cover memory-based design patterns in a separate video. Hence, we are keeping things simple and focused for now. So far, we have already implemented prompt and structured output using LangChain expression language. In this video, we will take the next step and implement state and history, state or history using LangGraph, specifically state graph to manage and maintain state across our workflow. Now, let's import the LangGraph. So, from langgraph dot graph import state graph. Now, what is a state graph? State graph is a graph based workflow abstraction from langgraph for orchestrating multi-step AI systems. It models execution as directed graph where nodes are Python functions and edges control execution flow. Each node reads from and writes to a shared state, typically defined using a type dict or a pydantic model. This design enables stateful deterministic workflow with support for branching, loop, parallel paths, and conditional routing, making it well suited for complex agent and orchestration scenario. In our case, we have 5 prompts. So we will model each one as a node. We will start by defining a shared state using a type dict to track messages and intermediate results. We then add and connect nodes, compile the graph into an executable artifact, and finally run it, starting from the initial state and terminating at the end. Alright, so as we need a type dict, let's import the type dict from typing underscore extension import typed dict, and we need one more data structure for our sections from typing import list. All right, let's create the class. Class content state, and we create inherit from typed dict, convert it to typed dict. Okay, what are the fields that we are going to have? First is the query that the user is going to pass. The query is a string. It's the initial query. Then we have ideas. It's again a string. It will contain the 5 topics or 5 ideas generated by an LLM. Then we have a topic. It is again a string. Now this will be the best idea selected out of 5. Then we have outline. It is again a string. Outline is a multi-line structured outline for the selected topic that is generated by the generate outline. All right. Now we have then sections. Again, it's a list of string. So what exactly a section is? It's a list of individually drafted sections per outline, and it is based on the points from the outline. For our use case, we have selected top 3, but it can be extended based on what is the requirement or the use case. Final content. Okay, final content is a string again, and this is the final reviewed and refined content that will be generated by the review chain. All right, we have missed the section chain, so let's create this section chain, and let's create the section prompt, then LLM, and finally we pipe the string output parser. All right, now let's pass this to graph. So let's create a graph with a state graph, and we have a value as content state. All right, couple of things here. So the content state is a type dict, and that defines a shared schema or the state graph for the state graph. Okay, it acts as a contract or the schema specifying every data fields that flow between the graph, as we have seen. But why type dict? It is type safe, it clearly communicates the expected shape of the data, and there is no class initialization overhead. Now, what actually happens with the state graph? So state graph will be using the schema for the content state. Now, let's go to the step 2. The step 2 is we need nodes. So each node is a Python function. All right, so we need nodes. Now, a node takes the state as the input and returns the update to the state. All right, nodes. All right, now this we have 5 prompts, so we will be having 5 nodes. State graph uses this class content state to understand the structure of the shared state that flows through all the graph nodes. Each graph node function receives the full state and returns a partial dictionary with the only field it updates. Finally, the lang graph automatically merges those partial update back into the full content state dictionary. So let's create the nodes. So first node would be the generate ideas. So let's create dev generate ideas. All right, and as discussed, it will take input as the state graph, the content state. This is the schema, and it is going to return a partial dictionary. So for now, let's put a dummy value. All right, before that, let's give us a doc string to understand. So it is to generate content ideas from the user query. All right, now let's return a dummy value as of now. So return, and it's going to return a partial dictionary. So let's return. So what it is going to return? Ideas. And let's have a placeholder, just an empty value. All right, the next node is the selection of topic. So let's create this dev select topic. All right, again it is going to take the state and the content state, and it is going to return the empty or partial dictionary. All right, so now let's give it a doc string. So it is select the best topic, or select the best topic from the generated idea, from the generated ideas. All right, now it is going to return, again we will return a partial dictionary, but for now we will give a placeholder. Later on we will fix everything. Okay, as of now we will try to understand the structure of the graph. Then the third is generate outline. Again same as before, state, and it will take a content state as an input, and it is, let's give it a doc string. So what it does, it will create a detailed outline for selected topic. Create a detailed outline for selected topic. All right, and let's return an empty value as of now. a partial dictionary with a key. So what will be the key? Because we are returning outline, so it is going to be outline, and finally an empty value. All right. Now then it will write a section. So dev write section. All right, which will again take a state, which is a content state, and same thing, we will provide a doc string for us to understand. Write individual sections based on the outline points. Write individual sections based on the outline points. All right, and we are going to return again a partial dictionary. This will return the value. So what we are going to return? Sections, which is going to be an empty list as of now. Later on we will populate. Then we have dev review content, which is going to review or provide us the review on draft. So it has the input value as state, again content state, and it will do the review. So let's name it as, or provide a doc string, review and refine the complete draft. All right, so let's return a partials dictionary here as well with a dummy value. So it's going to be, the key is final content with empty value. We have nodes. Now we need to establish our graph. That graph, once we are creating it, so this is a time to construct the graph, or we need to add the nodes to our graph. So how it is going to be? First we need to set the entry point from where the graph, or from where the graph is going to start. Entry point, it is going to be the first value. All right, before that let's add the node, then we will set the entry point. Add node. So first is the ideas. All right, and the node has a value, so it is going to be generate. Okay, let's fix spelling mistake, and we have here generate ideas. All right, we need to be very specific with these typos. All right, then graph dot add node, and next value is the select topic, which will have select topic. All right, this is the method that we are going to use here. The node is added, then we have graph dot add, and what is the next? Add node. Add node, the next value is outline. Here we will be using generate outline. All right, then we have graph dot add node, and we are going to do sections. It's going to write sections. All right, so it is going to be write section. All right, and finally we have a review. Add node. All right, so we are going to write a review content. Now we have 5 nodes added. Let's set the entry point. Graph dot set entry point, so it will start with ideas, generation of ideas. And now let's set the edges, because graph needs to know from where to where it has to go. All right, so let's set the edges. So graph dot add edge, Now from ideas, first node would be idea. Okay, then it should go to select topic, the second node. Let's copy paste it here. All right, it's a select topic. Then let's copy this all together, and we have select topic. So from select topic it will go to outline. Let's copy this again. We have to add another edge. From outline it should go to sections, so it should be outline, the incoming, and the outgoing would be sections. From sections it will go to review. All right, so from sections it will go to review, and finally from review it has to end. So let's do graph dot add edge. All right, so it has to be review. Now it has to end, so let's import the end from the graph itself, state graph. And however we can set the entry point like we had set the, we can set the exit point like we have set the entry point. So let's add the end here, end. All right, so this constitutes the graph. Now what next? So our graph is set, but the final point, we need to compile this graph. So let's create this app where we will compile the graph and make it an executable, graph.compile. All right, the graph is compiled. Finally we need to start the execution with an initial step. Nodes will be executed step by step using the edges, and the workflow will end with the end. All right, this video has run a bit longer than expected, so we will pause here. In part 3, we will continue with the implementation and complete the logic for each node. We will finish the context cascade pattern and see the entire content generation workflow in action. In the next video, we will talk about sequence activity diagram to clearly understand how the workflow executes step by step. Alright, if you enjoyed this video, please like and subscribe and stay tuned for the next part. Thank you.